Hello everyone. Today we're going to discuss about the liquid drop mass formula of a nuclei. Here the features of a nuclei are treated as that of a collective features of a liquid drop. For example, surface tension that tends to keep it spherical. This is specifically useful in case of explaining nuclear fission. Although the binding energy per nucleon will contribute to explaining the latent heat of vaporization analogy, the macroscopic parameters like volume, surface, and Coulomb terms are expected to contribute towards the binding energy as well. But in a nucleus, we have two microscopic bodies, which needs quantum mechanics, and these macroscopic parameters need classical mechanics. Therefore, the binding energy can be classified into four. The first one being the volume energy. Now, the volume energy is directly proportional to the number of nucleons. Basically, when the nucleons are packed in a nucleus, the number of nucleons surrounding one nucleon under consideration is same. So this explains the constant binding energy of each nucleon. Therefore, we can say mathematically, volume of nucleus is directly proportional to r cube is 4/3 pi r cube, which is directly proportional to r0 a to the power 1 by 3, a being the atomic mass, that cube. Therefore, is directly proportional to atomic mass. The second one being the surface energy term. This is necessary to consider because the nucleons at the surface of the nucleus interacts with fewer number of nucleons than those of inside the nucleus. Therefore, surface area is directly proportional to r square is linked to the surface term, and r0 a to the power 1 by 3 whole square, which is also equals to a to the power 2/3. The third one being the Coulomb energy term. The electric repulsion force between the protons in a nucleus tend to reduce the binding energy. To overcome this repulsion, we require an additional neutrons so that the nuclear force tend to balance out the repulsive force, and this effect accounts for lower stability in heavier nucleus for those with atomic number more than 80. Coulomb potential equals 1 by 4 pi epsilon naught into E square by R, and Coulomb term contributes to all such pairs as said. One nucleon under consideration with rest of the nucleon, therefore Z minus 1, considering all the nucleon pairs, is divided by 2 to separate out the other way around. For one neutron proton and one proton neutron, they're the same pair. That's why 2 is divided into the same as Coulomb potential, which is directly proportional to Z minus Z1 by R naught a to the power 1 by 3, or Z square by a to the power 1 by 3. The last one being the asymmetry term. This is a quantum mechanical term and arises due to Pauli's exclusion principle. If the Coulomb force were not there, the neutron and the proton number would be equal. In case of heavier nuclei, they contains more number of neutrons than proton to balance out the Coulomb repulsion. Some instability is introduced because of surplus neutrons occupy energy levels in nucleus which do not contain the proton. Asymmetry term introduces this correction factor and is proportional to n minus z whole square by a. We also take pairing term into account. This is from an empirical observation that even number of particles is more stable than the odd and is directly proportional to plus minus delta a to the power minus 3 by 4. Now, minus delta if n and z are odd, plus delta if n and z are even, and 0 if a is odd. Therefore, we have a volume energy term, a surface energy term, a Coulomb energy term, an asymmetric term, and in the end a pairing term. Therefore, the equation becomes binding energy equals to volumetric constant into volume energy term proportionality with A minus the surface energy term minus Coulomb repulsion term minus asymmetry term plus the pairing term. So this volume term basically explains the attraction experienced by the core nucleon due to its surroundings. So with the increasing volume, this will go on increasing, and also with the atomic mass. Similarly, the surface energy term, for example, with higher surface energy, the surface film has less stability. So basically, surface energy term contributes to reduce the binding energy. Similarly, the Coulomb repulsion will cause reduction of the binding energy, and so is the asymmetry term. And this pair production term is kept in positive because there are three conditions as we explained previously. So this is the liquid drop mass formula. Thank you. Please like, share and subscribe.